Let us suppose that you are taking the limit of f of x over g of x as x approaches a. And suppose that initial steps ended up with a 0 over 0 or infinity over infinity. What is your answer? You may be tempted to give an answer of 1. But wait, you cannot divide a number by 0, right? Also, infinity is not a number. Therefore, you cannot divide infinity by infinity. These ideas will be discussed in this first episode on L'Hopital's rule. In particular, we are going to discuss the 7 indeterminate forms and use L'Hopital's rule to evaluate limits involving 0 over 0 and infinity over infinity. Now, what are the 7 indeterminate forms? Any of these 7 representations is actually called an indeterminate form. And in this episode, we are going to consider the indeterminate forms 0 over 0 and infinity over infinity. Take note, these are not real numbers, and that infinity here can either be a positive infinity or a negative infinity. And you have seen this when you evaluated limits in sections 1.2 and 1.3. For example, if you are taking the limit of x squared minus 9 over x minus 3 as x approaches to 3, initial substitution will give you a 0 over 0. In the second case, you can verify this one, that this will also be a 0 over 0. The third case, see here that x is growing bigger and bigger, so the numerator grows bigger and bigger, and the denominator also grows bigger and bigger. The last case, we have the limit as x approaches to 0 from the right. Now ln of x goes to minus infinity, where 1 over x goes to positive infinity. So how are we going to deal with these types of indeterminate forms? For this one, we have to have a rule, and we call that rule the L'Hopital's rule. So basically, the L'Hopital's rule says that if you're taking the limit of a function f of x over g of x as x approaches a, and initial substitution gives you a 0 over 0 or an infinity over infinity, then what you're going to do is to take the derivative of your numerator divided by the derivative of your denominator, and after taking these derivatives individually, that is the time you're going to take the limit as x approaches to a. Now this rule also applies in the case x approaches a from the left, x approaches a from the right, x approaches minus infinity, and x approaches positive infinity. The only thing that is required here is that for the right hand side limit to exist. And what does it mean? That means that limit must be a real number. Now if it is not a real number, it must be positive infinity or negative infinity. So let's take the first example. So we are asked to find the limit of x squared minus 9 over x minus 3 as x approaches to 3. Now, initial substitution, if you substitute the variable by x equals to 3, then we will have 3 squared minus 9 over 3 minus 3. And this will give us a 0 over 0. So L'Hopital's rule says, what you do is to take the derivative of your numerator and take the derivative of your denominator. And after taking these derivatives, we will take the limit as x approaches to 3. So let's simplify this one. This is limit as x approaches to 3. Derivative of x squared minus 9 is just 2x. And the derivative of x minus 3 is just 1. Rewriting this one, limit as x approaches to 3 of 2x. This is now a simple limit. All you have to do is to replace the variable by 3. So this will be 2 times 3. And your final answer will be 6. Let's take a second example. This time we are going to take the limit of x squared plus 1 over 1 minus 5x squared as x approaches positive infinity. Now what does it mean for x to approach positive infinity? That means x is growing bigger and bigger. Now, the behavior of the numerator as x grows bigger and bigger, x squared plus 1 will be a very big number as well. So this numerator will go to positive infinity. On the other hand, as x grows bigger and bigger, take note that x squared will grow bigger and bigger, but there is a minus 5 multiplied to that. So the net effect will be the denominator will grow smaller and smaller. So, but don't worry, this is still an indeterminate form, infinity over infinity, because as I mentioned earlier, infinity here can either be a positive infinity or a negative infinity. So L'Hopital's rule says that all we have to do is to take the derivative of our numerator, and then we will also take the derivative of the denominator, and after individually taking their derivatives, we take the limit as x approaches positive infinity. Simplifying this one, we'll have limit as x approaches positive infinity. The derivative of x squared is just 2x. The derivative of 1 is 0. So the derivative of 1 is 0, and the derivative of minus 5x squared is minus 10x. So in this case, we can cancel the x, and then we can rewrite this as the limit as x approaches positive infinity. Take note, 2 over minus 10 is just equal to 2 times 1 over minus 5 times 2. We can cancel the 2, so this will be just minus 1/5. Now remember, when you have your limit rules, that the limit of a constant, take note, negative 1/5 is just a constant, and the rule says the limit of a constant is just this constant. So that means we will have an answer of minus 1/5. Or you can place the minus at the bottom. Lastly, let's take the case wherein we have limit e to the x over x squared as x approaches positive infinity. Now, as x grows bigger and bigger, e to the x grows bigger and bigger as well. Well, x squared also grows bigger and bigger. So this is an infinity over infinity indeterminate form. L'Hopital's rule says we have to take the derivative of the numerator and then take the derivative of the denominator, and after that we have to take the limit as x approaches positive infinity. So let's rewrite this one. This will be limit as x approaches positive infinity. The derivative of e to the x is just e to the x. The derivative of x squared is just 2x. Now let's try to analyze this again. As x grows bigger and bigger, e to the x will grow bigger and bigger as well. And as x grows bigger and bigger, 2 multiplied by x will also grow bigger and bigger. And what do we have now? It's the same infinity over infinity case. So in this case, we have to apply L'Hopital's rule another time. So we take limit as x approaches positive infinity, and all we have to do is to take the derivative of the numerator and then take the derivative of the denominator. So simplify this one, we will get limit as x approaches positive infinity. Derivative of e to the x is just e to the x. Derivative of 2x is just 2. I can actually remove 1/2 outside of the limit and write this 1/2 times limit as x approaches positive infinity of e to the x. But take note, the limit of e to the x as x approaches positive infinity goes to positive infinity. Well, multiplying positive infinity by positive number will still be positive infinity. Now, before I end this discussion, I will just make some comment here. Actually, you can generalize this formula to limit of e to the x over x to the n as x approaches positive infinity. And here is positive. And this will still be a positive infinity, just like in the previous example where n is 2. So it can be 3x cubed, x to the fourth, x to the fifth. Now this means actually that the exponential function e to the x grows faster than x to the power n. Now, that only means that the numerator is getting bigger and bigger faster than the denominator. Now, what happens now if we replace the position of x to the n and e to the x? Now, this time, since exponential function grows faster, the denominator is getting bigger and bigger faster than the numerator. So the net effect will be this number will go to 0. And that's it. Thank you.